And now going to part B. Part B says the displacement s in meters of a moving object after time t seconds is given by. So in part B, the expression for the displacement of a moving object after a given time t is defined by s equals to t cubed plus 3t squared minus 8t plus 2. This is the expression for the displacement at any time t. Now, it is the question that guides us on where to start. Roman 1 says, find the velocity when the time is 2 seconds. So, velocity. Now, before we consider the given time, let us first know the relationship between the velocity and the displacement. The relationship is that velocity is the rate of change of displacement. Therefore, the velocity v is ds dt. ds dt is the rate of change of displacement at any time t. Now, from here, for us to get ds dt, we need to differentiate the given function of displacement. So ds dt equals to, if we differentiate this function, which you can do, it gives us 3t squared plus 6t minus 8. Okay, this is ds dt, which is the rate of change of displacement at any time. Therefore, velocity at any time is the same as the rate of change of displacement at any time. So therefore, v equals to 3t squared plus 6t minus 8. So this is the expression for velocity at any time t. This is the function that defines for us the velocity at any time t. But now the question says at t equal to 2 seconds. Now, when t is 2 seconds, when t is 2 seconds, what is now the velocity at that time t equals to 2 seconds? You simply come and substitute for that time in the general expression for velocity at any time t. Therefore, our velocity now becomes, we have 3t. Our t now is 2. 3t, but it's t squared, so square 2 plus 6t. Our t is still 2, then minus 8. Then we simplify this. It is 12 plus 12 minus 8 is around 16. 2 squared times 3 plus 12 minus 8, 16. 16 meters per square second. Why are we saying that? It is velocity. So when the time is 2 seconds, this object is moving at a speed of 16 meters per second. That is the solution for part A. For Roman 1, going to Roman 2. Roman 2 is asking for acceleration. Acceleration. Now, before you proceed, define acceleration to guide you in mathematical representation. Acceleration is the rate of change of velocity. Okay, it is the rate of change of velocity. That means acceleration equals to dv dt. dv dt is the rate of change of velocity. Now, for us to get dv dt, we must know the expression for velocity at any time, which is here. But our v is 3t squared plus 6t minus 8. This is the expression for velocity at any time. But now, acceleration says what is the rate of change of velocity at any time? That means we must get dv dt, which is the rate of change of velocity. So in simple terms, we differentiate the given function of velocity. So dv dt equals to, since you know differentiation, I'm not explaining how I'm differentiating this, but it gives us 60 plus 6. Okay, so this is the rate of change of velocity, that is dv dt. But dv dt is what we are calling acceleration. Therefore, acceleration is 60 plus 6. This is the expression for acceleration at any time t. Okay, in other words, that is the rate of change of velocity at any time t. So this expression works for any given time or for any given duration that the particle has moved. Now, our question was saying when time is 4 seconds. So this is the expression for any time t. But what if time is 4 now? Then you come and say when the time is now 4 seconds, what is my acceleration at this time of motion? That means acceleration now become 6t. Our t is now 4. Okay, 6t. Our t is 4, but there is plus 6. Then you press the calculator. It's around 30. 6 times 4, 24, plus 6, 30. So here you get 30 meters per squared second. Remember, this is acceleration. So the acceleration of this particle when the time is 4 seconds is 30 meters per squared second. And this makes the solution to example 1.